The Subcommittee on Energy will come to order. Without objection, the chair is authorized to declare recesses of the subcommittee at any time. Welcome to today's hearing entitled Advancing Solar Energy Research Trumps Deployment. I recognize myself for 5 minutes for an opening statement. Good morning. Appreciate y'all being here. Today we will examine the status of U.S. research in solar energy and explore the future of this administration's effort to refocus funding on early-stage research and innovative technology. This September, the Department of Energy's Office of Energy Efficiency and Renewable Energy, or EERE, announced that the cost of utility-scale solar power has met the Sunshot 2020 goal of under 6 cents per kilowatt hour. This is an incredible achievement by solar power companies across the country, including many in my home state of Texas. More importantly, with this new benchmark, EERE announced a new direction in solar energy research, prioritizing early-stage research and emerging solar energy technology instead of cost reductions for commercially available technology. This new research will focus on two primary areas. The first is innovative technology in concentrating solar power, or CSP systems, which use mirrors to reflect and concentrate sunlight onto a focused point in order to heat water and create steam to power turbines and create electricity. The second research priority relates to power electronics technologies. This technology connects solar photovoltaic PV arrays to the electrical grid. Advancements in power electronics will help grid operators and consumers to manage electricity use. EERE also recently released the FY 2018-2022 multi-year program early stage research for PV technology, for grid integration, for PV materials, and for concentrating solar thermal power. EERE will focus on advancements in fundamental technologies and research in material science that will drive solar energy innovation forward. For example, at the National Renewable Energy Lab, NREL, materials science research is advancing the capabilities of solar energy technology. As you will hear from NREL Lab Director Dr. Martin Keller, linking basic and early-stage research in materials to applied solar energy research can produce major breakthroughs in this area of technology. One example is the lab's experiments with perovskite solar cell technology, which uses a low-cost and high-efficiency material that has widespread application prospects. Perovskites may provide a low-cost and scalable material for solar cells or semiconductors and could lead to more efficient solar technology. Perovskite solar cells have the potential for a, quote, roll-on, end quote, application, similar to printing newspapers, and research in materials science at NREL could provide a fundamentally new way for industry to actually manufacture solar cells. These research breakthroughs can transform energy markets far more than using limited research dollars to push deployment of today's existing solar technology. Congress should focus on making America the global leader in research and innovation in the energy sector. We do not need to pick winners and losers in energy markets to support next generation technology. I want to thank our accomplished panel of witnesses for testifying today, and I look forward to a productive discussion about the future of solar energy research. And with that, I recognize the ranking member, Ms. Rosen.
Thank you. Good afternoon, and thank you, Chairman Weber, for holding this important and timely hearing today. You know, it's been more than 5 years since this committee has last held a hearing specifically on solar energy. With the expanding deployment of solar power across our nation, the incredible advances made in this area over the past 5 years, I'm very glad we're getting a chance to re-examine these technologies. I'd also like to thank the distinguished panel of witnesses for being here. I'm very interested in what all of you have to say that will help us further enable the development of this critical resource and this critical industry. Solar energy is an important and growing portion of our nation's energy consumption. Its success is not only because it is a clean and renewable energy source, but also because it has become cost competitive with other types of energy In my state of Nevada, we are currently getting about 9% of our energy needs from solar technology and have doubled the amount of megawatts installed in the past year. In fact, a year ago, the city of Las Vegas fulfilled its promise to run all of its municipal facilities to 100% renewable energy. On a personal level, I know firsthand from my life before Congress the enormous benefits of solar energy. As a former president of Nevada's largest synagogue, I helped facilitate the installation of one of the largest solar projects by a nonprofit in Henderson, Nevada, cutting our energy costs by nearly 70%. I'm optimistic that the growth of solar will continue because of the research being carried out at our national labs, universities, and in American solar companies. For more than a decade, the University of Nevada, Las Vegas has engaged in extensive research on renewable energy, and recently its solar decathlon team took first place for innovation and second place for both engineering and architecture in the national DOE competition. UNLV is also leading an initiative to establish a Solar Solutions Center designed to employ research, policy analysis, and the business community to create solar energy jobs and improve technology. Strong investments in R&D will be vital to decreasing the cost of solar energy. However, I'm concerned about the consistent attacks on solar energy from both the current administration and the Republican-led Congress. The administration's proposed cuts of over 2/3 to the DOE's solar technology program budget will have a profound and negative impact on our nation's ability to utilize this resource for the benefit for our environment and our economy. Solar energy is less expensive now than it ever has been, and it can continue to become more affordable, saving our constituents and small businesses money. In addition, I am deeply concerned by the Republican tax bill that, among other incredibly harmful provisions, will hurt our solar industry by eliminating the 10% investment tax credit for large-scale solar projects. I submitted an amendment to prevent the eventual elimination of tax credits for solar and geothermal energy, which unfortunately the majority refused to adopt. While this administration and my Republican colleagues are trying to justify reducing U.S. investments in solar, China is spending more than double the United States on renewables, with initiatives to continue spending through 2030 at levels that far outstrip the United States. Without strong support investment by the federal government, we're likely to lose jobs in this growing industry and the opportunity to control our own energy future. My state of Nevada currently has over 8,000 solar jobs, and the projected solar growth is over 20%. We should be continuing to invest in the solar energy sector to create more jobs, not gutting proven programs that work. The next breakthroughs in solar energy are coming, whether here in the U.S. or somewhere else. The only question is whether the U.S. will lead the way or whether we will pay foreign companies for our energy needs and lose jobs overseas. I'm looking forward to what the witnesses have to say about how we keep these jobs in our country and achieve the clean energy future that our citizens deserve. Thank you.
Thank you, Ms. Rosen. I now recognize the chairman of the full committee, Mr. Smith.
Thank you, Mr. Chairman. Today, the Subcommittee on Energy will examine the Department of Energy's efforts to refocus the solar energy program on early-stage research and breakthrough solar technologies. This hearing specifically will consider the rapid integration of solar energy technology in the energy market and discuss the appropriate role of DOE investment in solar energy research in the future. Fundamental science and technological capabilities still challenge solar energy advancement, but it is crucial that the department focus on basic and early-stage research that cannot be conducted by the private sector. For too long, the American public saw their taxpayer funds pick winners and losers in the energy market. The previous administration often played favorites and invested heavily in the deployment of photovoltaic technology into energy markets. While this approach may have sped the deployment of today's solar energy, it did not lead to the kind of breakthrough technology in solar energy manufacturing and energy storage that is needed to help solar energy compete without tax credits, mandates, or subsidies. This committee supports DOE's role in funding basic and early-stage research that the private sector is truly unable to explore on its own. It is these kinds of breakthroughs in new materials, electrochemistry, and advanced manufacturing that will lead to the next generation of solar energy technology. The President's fiscal year 2018 budget request also supports investment in early-stage applied research in solar energy. The budget request directs federal investment into the kind of research that industry cannot support and that can lead to new solar energy technology. This clearly signals the administration's push for American energy dominance and independence. And I want to welcome Mr. Daniel Simmons, the Principal Deputy Assistant Energy for EERE, to testify today. It is critical that we hear directly from the Department of Policy changes and the direction of DOE research programs. I thank our witnesses today for testifying about their valuable efforts in renewable energy programs research and for sharing their insights into emerging solar energy technology. I look forward to a productive discussion about early-stage research at DOE and the right approach to federal research investment. Thank you, Mr. Chairman, and yield back.
Thank you, Ms. Smith. I now recognize the ranking member of the full committee for a statement, Ms. Johnson.
Thank you very much, Mr. Chairman, and I appreciate you holding this hearing. It has been several years since this committee has held a hearing that closely examined solar energy research and development activities carried out by the Department of Energy. These years have been a very consequential time for this sector. We've seen the price of solar energy decrease dramatically, and solar deployment continues to grow here in the U.S. and around the world. The Solar Energy Technologies Office within DOE's Office of Energy Efficiency and Renewable Energy has stewarded key research that has resulted in important innovations in the diverse commercial market for solar energy. Moreover, due in large part to investments enabled by the Loans Program Office of DOE, the United States now has a vibrant and growing utility-scale solar industry. In that regard, I'd like to congratulate the scientists and researchers at the Department of Energy, the national laboratories, and their private sector partners that helped us achieve a milestone in the Sunshot Initiative. Just this past September, DOE announced that the program achieved the cost reduction goals for utility-scale solar 3 years early. These smart government investments have resulted in significant private sector investments here in the U.S., which has led to a vibrant solar industry and well-paying jobs for Americans across the country. Unfortunately, this administration and some of my colleagues in Congress do not recognize the realities in this industry. If we do not invest, others will. In fact, our international competitors have been investing and will continue to prioritize solar technology development. China is clearly beating us at our own game. Meanwhile, we are quibbling about whether the federal government should invest in late-stage research or just early-stage activities, whatever that means, instead of supporting robust R&D investments across the innovation spectrum that will make the U.S. more competitive. The Trump administration's budget proposed major cuts in solar energy R&D, including a 66% cut from prior year funding for the Solar Energy Technologies Office within EERE. It also called for an outright elimination of the Loans Programs Office, which enabled the commercialization of several first-of-a-kind large-scale solar power projects. Now, I'm not going to tell you that every program the department currently implements is perfect. That wouldn't be research. I wouldn't tell you that reform should not be considered, or that reasonable people cannot simply disagree on the best way to allocate its resources, even after a careful, rigorous review. One of my primary concerns now is that such a thoughtful review never actually took place before proposing these draconian cuts. In fact, administration officials confirmed after they released the budget that there was no engagement with the private sector to determine what industry would be able or willing to fund in the absence of the federal investment. That is simply unacceptable. Defunding solar energy at DOE may be a nice political talking point for some, but when it comes to U.S. competitiveness and our economic growth, such a proposal is ill-advised and short-sighted. I am hoping we can have a productive dialogue today that will better inform us about the realities of this industry both here and around the world. We need to know what we have to lose before we are slashing the R&D budgets that are the livelihood and likelihood of any future economy. I thank you, Mr. Chairman, for having the hearing, and I yield back.
Thank the gentlelady from Texas. Today, our first witness is Mr. Daniel Simmons, Principal Deputy Assistant Secretary, Office of Energy Efficiency and Renewable Energy at the Department of Energy. Previously, Mr. Simmons served as the Institute for Energy Research's Vice President for Policy, Director of the National Resources Task Force at the American Legislative Exchange Council, and was a research fellow at the Mercatus Center. Mr. Simmons received his bachelor's degree from Utah State University and his law degree from George Mason University School of Law. Welcome, Mr. Simmons. Our second witness today is Dr. Martin Keller, Director at the National Renewable Energy Laboratory. Previously, Dr. Keller served as the Associate Laboratory Director for Energy and Environmental Sciences at Oak Ridge National Laboratory. He received his doctorate in microbiology from the University of Regensburg in Germany. Welcome to you. Our third witness is Dr. Steve, is it Eglash? Okay. Executive Director of Strategic Research Initiatives in the Computer Science Department at Stanford University. Previously, Dr. Eglash was President and CEO of the solar energy company Cerium Technologies, as well as a consultant for the National Renewable Energy Laboratory and the U.S. Department of Energy. Dr. Eglash received his Ph.D. and M.S. from Stanford University and his bachelor's degree from the University of California at Berkeley, all in electrical engineering. Welcome, Dr. Eglash. Our last witness today is Mr. Kenny Stein, Director of Policy at the Institute for Energy Research. Previously, Mr. Stein worked in policy roles at FreedomWorks and the American Legislative Exchange Council. He received his law degree from the University of Houston. You're a cougar. Me too. Good for you. Let the record show that Mr. Stein's testimony will carry a double credence here today. He received his law degree from the University of Houston and his bachelor's degree from American University. Welcome, Mr. Stein. I now recognize Mr. Simmons for 5 minutes to present his testimony. Be sure your mic's on, please.
Good afternoon, Chairman Smith, Chairman Weber, Ranking Member Johnson, VC, and Ms. Rosen, and members of the committee. Thank you for inviting the Department of Energy to testify. My name is Daniel Simmons, and I am the Principal Deputy Assistant Secretary for Energy Efficiency and Renewable Energy at the Department of Energy. Solar energy technologies are an important source of energy for our nation, and I thank you for the opportunity to discuss our research to advance these technologies. 10 years ago, the solar market looked very different than it does today. There were only 1.1 gigawatts installed in the United States, representing less than 0.01% of the nation's energy mix. Now there are more than 50 gigawatts installed, providing 1% of U.S. electricity and growing rapidly. Over 80% of the solar ever installed was installed in the last 5 years, and in the next 5 years, it is projected to triple. Over the past 10 years, solar costs have declined dramatically. For example, earlier this year, as Chairman Weber noted, the Solar Energy Technology Office announced that the industry met the Sunshot utility scale cost goal of 6 cents per kilowatt hour 3 years early. While there are many reasons for solar prices to have declined and installations to have risen, federal research and development plays a role. This administration is committed to developing a wide range of energy resources through R&D and believes that federal funding should prioritize basic and early stage applied research. As stated in the Joint Office of Management and Budget and the Office of Science and Technology Policy Memo on R&D priority areas for the FY19 budget formulation, quote, American leadership in science and technology is critical to achieving this administration's higher priorities: national security, economic growth, and job creation. American ingenuity combined with free market capitalism have driven and will continue to drive tremendous technological breakthroughs. Development of domestic energy sources should be the basis for a clean energy portfolio composed of fossil, nuclear, and renewable energy sources. Agencies should invest in early-stage, innovative technologies that show promise in harnessing American energy resources safely and efficiently. As proposed in the President's FY18 budget, federally funded energy R&D should continue to reflect an increased reliance on the private sector to fund later-stage research development and commercialization of energy technologies." End quote. DOE's Solar Energy Technology Office focuses primarily on reducing the cost of various solar technologies, including photovoltaic and concentrating solar thermal power. The dramatic cost reductions in solar technology provide an opportunity for the administration to refocus the Solar Office's research on a longer-term challenge, grid integration. In the long term, the primary challenge facing solar is not necessarily cost, but reliability and integration of solar power into the grid. While lower prices have helped drive new capacity installations, more work is needed to make solar a reliable, on-demand energy resource. This year, DOE has approved over $100 million in financial assistance to advance our early-stage research priorities around solar reliability and grid integration. Examples include up to $62 million to support advances in concentrated solar power technologies, up to $20 million is dedicated to early-stage projects to advance solar power or to advance power electronics technologies. That is the interface between the grid and solar panels, and up to $10 million to support improved solar forecasting. Each of these research areas will help make it easier to integrate solar energy into the electric grid. In addition to this work, EERE works with the Office of Electricity, Delivery, and Energy Reliability through DOE's Grid Modernization Initiative. One important focus is researching solar plus storage. Energy storage allows variable sources of energy, such as solar, to be used when it's needed the most. While solar power, making solar power available when energy is needed is the most critical challenge for the solar industry today. DOE's solar R&D is focused on these critical energy challenges of grid reliability, resilience, and integration. EERE will continue to focus on early-stage research and development to advance solar technologies while forging strong partnerships with the private sector to maximize the impact of federal funding. Thank you for the opportunity to testify today, and I look forward to answering your questions.
Thank you, Ms. Simmons. You ended right on zero. Dr. Keller, you're recognized for 5 minutes.
Yeah. So Chairman Weber, Chairman Smith, Ranking Member Weasley, Rosen, Johnson, and our own Congressman Perlmutter. Members of the subcommittee, thank you for this opportunity to address the future research opportunities for solar energy and the many benefits advanced solar technologies can deliver for our nation. I'm Martin Keller. I'm the director of the U.S. Department of Energy's National Renewable Energy Laboratory, or commonly called NREL, based in Golden, Colorado. My career has included research positions in the private sector and more than a decade within the National Lab Complex. I previously was an associate laboratory director at Oak Ridge National Laboratory, and before that led the technology development for a San Diego-based startup company. I hold a doctorate in microbiology from the University of Regensburg in Germany, and my entire career has been about integrating foundational science into important new applications. In my view, the subject of today's hearing could not be more timely, nor more important to the energy future of our country. Although solar energy accounts for about 1.8% of U.S. electrical generation today, it is on a remarkable trajectory of growth. Last year, solar was the nation's leading source of new electric generation capacity. It's also an economic force. More than 260,000 Americans are employed in the solar industry, with 51,000 jobs added just in 2016. This marked the fourth consecutive year of more than 20% growth. Our research has made incredible progress on bringing solar technologies into the mainstream, and solar is in fact becoming competitive with conventional power from the grid. This said, we cannot afford to slow our progress on innovating solar technology. To achieve solar potential, an ongoing program of federally supported early-stage research is needed. NREL and other national labs have the world-class expertise and the unique facilities to lead this effort. I would like to share with you examples of how early-stage research can deliver potential game-changing breakthroughs in solar research. Fundamental material research in the solar area explored a new class of PV materials called perovskites. These materials hold a great promise to increase efficiency while cutting costs. One of the benefits of these materials is the potential of extremely high-speed manufacturing. Just imagine solar cells being produced at the rate of speed that a newspaper is produced on a commercial printing press. What is now needed is a federally supported hub for perovskite research, coordinating the work of industry, universities, and national labs to deliver breakthroughs needed to swiftly bring this technology to the market. Other examples are further development of lightweight PV materials and new production methods for very high-efficient layered solar cells. Lightweight PV materials are becoming increasingly important to the US military to power the computers and communication systems of our soldiers on the ground. Very high-efficient solar cells, manufactured through much cheaper processes, may eventually give our military's drones the commanding power of perpetual flight. We are optimistic that the several research efforts I just outlined could bring about a revolution in PV technology and inject new vitality into US-based solar manufacturing. Even with advances in grid integration technology, we will certainly need storage technologies. Because of this, storage for solar energy warrants complementary research dedicated to its own unique requirements. As distributed solar generation becomes a larger part of the generation mix, our electric grid systems have the potential to become even stronger with greater flexibility and resilience. Energy integration at this complex level presents a deep scientific challenge. This research path is crucial not only for solar, but for the entire US electric grid. As solar power becomes more prevalent in the United States, we will be able to utilize surplus solar power to enhance economic competitiveness. We potentially can convert solar electricity or heat into valuable products like fuels, hydrogen, or other chemicals. We can provide an economic advantage to US industry through sustained scientific research along these multiple pathways. In addition to solar photovoltaic technologies, concentrating solar power, or CSP, has significant potential as well. Here, we need to develop systems that run at higher temperatures and boost operating efficiency. And since CSP can use thermal energy to expand the period in which it produces power, CSP could give grid operators considerable flexibility from providing baseload to peaking generation. As we contemplate the research portfolio for the years ahead, we should remember that other nations are currently ramping up their own government to support solar research. If we fail to maintain our innovation leadership in solar, others will be happy to take our place. In conclusion, I am not exaggerating when I say that researchers at my laboratory and around the country are excited and eager to tackle these challenges and bring us to important advancements in solar technology that we need for our nation's energy future.
All right, thank you, Dr. Keller. You were 1 second over. Dr. Eglash, you've got to get with the program. You're recognized for 5 minutes.
Chairman Weber, Ranking Member Rosen, Chairman Smith, Ranking Member Johnson, and members of the subcommittee, thank you for the opportunity to appear before you today. There's tremendous benefit to continued federal investment in research in solar energy and other fields, because this investment improves U.S. industrial competitiveness, strengthens our nation's economy, and creates jobs. Industry can't afford this research on its own because the technologies are too numerous and broad, each individual project too risky, and in some cases the time to payoff too long. Federally funded research must be appropriately focused and effectively managed if it is to lead to good return on investment and benefit for U.S. industry. Fortunately, we can turn to exemplary models and identify best practices. The U.S. government, academia, and industry each have unique roles and have to work together across the entire innovation pipeline. Government has the resources to fund research, act as a bridging institution, and convene across academia, national labs, and industry. Universities and national labs are excellent places for innovative research. Industry has insights on real-world opportunities and challenges, as well as the resources for commercialization and large-scale impact. Recent progress in reductions in the cost of solar electricity has accelerated the deployment of residential and utility-scale solar. But as impressive as this is, it is only the beginning and there is a need to go further. Further reductions in the cost of solar electricity will lead to higher levels of penetration and will lower the average cost of electricity. The next steps in solar panel research are higher performance through new and improved materials, larger panels leading to reduced cost of manufacturing and installation, reduced capital equipment costs for factories, and improved reliability for longer lifetimes. Further DOE-funded research in solar energy is important for another reason. It is critical to U.S. competitiveness. If the U.S. develops technology for the next generation of improvements in photovoltaics, then we have an opportunity to expand manufacturing and increase jobs. If the U.S. doesn't do this research, then other countries will, and they will reap the benefits instead of us. The Bay Area Photovoltaic Consortium is an exemplary model for federally funded research. It was created in 2011 by the U.S. Department of Energy, Stanford University, and the University of California at Berkeley. The objective of the Bay Area PV Consortium is to perform industry-relevant cutting-edge research on photovoltaic modules, enabling high efficiency and low production costs, thereby strengthening the U.S. photovoltaic industry. The Bay Area PV Consortium established a new structure where industry sets the research priorities, professors at universities develop research proposals and conduct the research, and the DOE, academia, and industry work together to manage the program. The nature of the research is foundational to develop the knowledge base. It's not industrial policy, subsidies, or the government picking winners and losers. Rather, it's research that the industry will not undertake by itself because of the risk and time to payoff. The Bay Area PV Consortium developed innovative technologies in close cooperation with industry that facilitated technology transfer and commercialization. It educated and trained a large number of graduate students and postdocs, thereby contributing to workforce development. The Bay Area PV Consortium created an interactive ecosystem comprising leaders from government, universities, national labs, and industry. The resultant interactions and collaborations catalyzed a generation of disruptive ideas. The success of the Bay Area PV Consortium is due in part to a seamless integration of research and application that was responsive to the needs of industry, the ideas of researchers, and the priorities of the DOE. Of course, the Bay Area PV Consortium is just one piece of a larger research infrastructure where support for innovative and impactful research is contributing to our nation's success. Federally funded research on technologies such as solar energy helps U.S. competitiveness and creates jobs. Continued U.S. Department of Energy funding for solar energy research will strengthen and expand the U.S. solar industry, reduce energy costs, and improve our energy independence. Public-private partnerships assure that federally funded research targets the right problems and results in successful technology transfer to U.S. energy industry.
You guys are good. Mr. Stein, you're up for 5 minutes.
Mr. Chairman, thank you for the opportunity to participate in this subcommittee hearing on federal government involvement in solar research. My name is Kenny Stein. I'm the Policy Director for the Institute for Energy Research. The purpose of federal government funding for research in any industry should be clearly defined. The justification for such funding is that research in emerging or novel technologies would not otherwise be provided by private interests, whether companies or individuals. This is a reasonable role for the federal government to play. However, this cannot be a license to spend money. Federal support should not go to projects that private interests already have a clear incentive to develop. Far too often it is the case that the federal government provides grant money to companies to subsidize activities that they would already be undertaking. Perfect illustration of this failure of mission is the Sunshot Initiative. Launched by the Department of Energy in 2011, this move sought to reduce the cost of solar energy systems so that they could become cost competitive with other forms of energy. Simply put, that is a political goal, not a research goal. It is not the federal government's responsibility to support the success or spread of a given technology or way of operating. Any solar manufacturer or operator already has an overwhelming market incentive to lower costs. Offering government money in addition to existing economic incentives does not add to the well-being of the American people or address some unmet need of the federal government itself. It simply subsidizes activities which private interests are already doing. Indeed, government funding often crowds out private funding when it enters a given area, limiting the overall level of investment and spurring calls for even more government spending to make up for the exit of private investment. The federal government, slow and process constrained as it is, cannot adjust rapidly to technological developments. As new operating processes or products enter the market, it can be left funding old or obsolete initiatives. Getting locked in on lowering the cost of existing solar technologies does nothing to support emerging or novel technologies. Indeed, in another form of crowding out, this federal focus can lead an industry to spend its time trying to meet federal benchmarks rather than asking the question whether alternatives might make more sense, which ironically limits innovation in the given industry. The Sunshot Initiative has tried claiming victory as the costs of solar installations have indeed fallen, but how much of that cost decline is because of federal research spending rather than Chinese manufacturing innovation, tax support from the investment tax credit, state renewables mandates, or the simple financial imperative to make money? The fact that that is an impossible question to answer suggests the folly of the Sunshot Initiative. Sunshot was not about research, it was about picking winners and losers, arbitrarily seeking to improve the economics of certain solar applications because of the political preferences of the administration of the time. A more appropriate role for the Department of Energy can be found in the earliest days with solar energy generation technology. Early solar panels with poor efficiency found little uptake for terrestrial uses. However, the burgeoning space program identified solar as a potential energy source for spacecraft. Government funding from NASA helped develop nascent solar technologies to the point where it was usable in space applications. And years later, solar companies built on that foundation to develop the generation technologies that are now being applied to terrestrial electricity generation. The lesson here is that the federal government didn't choose a solar technology and then try to commercialize it or reduce its costs. The basic technology was developed for a specific national purpose, with private innovation later finding applications for the private market. This is how the process should work. The federal government does not have the characteristics or competency to be a startup incubator, but it can effectively provide a base level of data and information for private innovators to build on. Thus, a better path forward for the Department of Energy would be focusing on the original mission that I suggested above, funding emerging or novel technologies and applications not otherwise supported by private interests. There is a legitimate federal role in supporting such basic research that has the potential to improve the overall well-being of the American people, or is required to meet a specific federal need. The current administration has indicated an interest in reorienting federal policies to early-stage research. I applaud this goal and look forward to seeing how that initiative develops. In closing, I will note, however, that this pivot should not just be a branding exercise with anything called early stage eligible for funding. Federal research spending should focus on truly novel technologies or applications. Further, this should not be a license to spend more money. Clearly focusing federal priorities means discarding some spending areas to hone in on truly basic research, a case where less is better. Thank you for the invitation to participate in this evolving discussion.
Thank you, sir. The chair will now recognize himself for 5 minutes. Mr. Simmons, how specifically has the DOE changed its priorities to fund more early-stage research and technological development?
In the areas that I outlined, it makes sense to spend money, say, on concentrated solar power for the value of that it can have to grid reliability, for things like power electronics, because power electronics are really the bridge between power cells and the electrical grid, and it can provide, and better power electronics can help provide important services to the grid. So those are two ways, as well as working for solar forecasting to make sure that we're focused on these making sure that we have better solar forecasts so that solar is better integrated into the grid. So it is making sure that we focus very much on this, earlier stage projects and less on deployment.
All right, thank you. Dr. Keller, you've heard the department's announcement to focus more on early stage research within EERE. Okay. So what impact could this refocus have on the direction and projects undertaken at your lab?
So as I outlined in my testimony, we have a lot of early stage research going on. So I applaud the department for focusing on the early stage. This said, I think it's also important that we having a balanced portfolio. I think it's very important that we looking into holistically into this research, because you need to look at this in an integrated way. So I think we need to continue to drive early stage research to de-risk some of these new technologies, what industry cannot do. And then we also have to have a research portfolio to help to transition this technology to industry.
You mentioned several areas of fundamental science in your testimony.
Yeah.
Can you explain how these areas help the solar industry?
I'll give you perovskite as an example. This is a very early stage research. If we are successful to overcome some of the limitation on these materials, their stability concerns, for example, moisture sensitivity, this will lead to a revolution in the way we're making solar cells. So I showed you this, that you can use this so-called roll-to-roll, that you can produce solar cells in the way you're doing newspapers, because this will lead to an ink. So suddenly you can have solar panels in ways, in areas where we even have no chance right now to go into. So this is one of this, what I call game-changing technologies.
Not to mention the rapid production.
That's exactly what this is, roll-to-roll. So it's almost like an ink. So you bring this down to a carrier like you would bring down ink onto a newspaper. This can be a revolution in the way we're making solar panels.
Sure. Mr. Stein, you talked about the proper role of federal government. So in your opinion, what is the proper role of the federal government when it comes to funding priorities for applied energy research?
Well, I think the category that I sort of outlined is that the idea that this is something that is not being funded and will not be funded by private interest or individuals.
Well, should we preempt that with the need for it first?
Well, the need for it, I think that
You have to have a need before you decide you want to go into research how to fix that need. True stuff?
Yes, that's certainly true. But the part of the problem with the government funding all these things is knowing what that need is.
Right.
The government isn't necessarily good at identifying those things.
Heck, you say.
You could have private companies can think of novel applications for some of these things that the government just doesn't have the capacity or the management process to come up with those.
So when that need's identified, when that process is identified, should the federal government fund late-stage consortiums where industry is already involved in developing solar energy technology?
Well, I would say no, simply because once it's already, the technology is proven, once the data and research is there, it's private companies going out and finding a way to economically produce that and apply it in the private market.
Thank you. I've got about 30 seconds left, and I want to just make a couple of observations. I think there's about 4 steps to this, and Dr. Eglash, you may be the best one. You hit the degrees in engineering, right? Seems like there's 4 steps to solar. Concentrate it, capture it, store it, and then release it efficiently. Is that fair?
Yes, that's fair.
Okay. So where do you think, very quickly, I'm out of seconds here, but where do you think the most innovation needs to happen out of those 4?
There's still a lot of opportunity for innovation in making solar panels better, more efficient, and lower cost and longer
So
lived.
that's the storage part that could release it efficiently.
That's the process of converting sunlight into electricity, the amount of electricity that we can produce for a given panel or a given dollar invested. And then integrating that electricity with the rest of the electric grid, with storage, with loads in buildings. and
That's the
transport.
releasing it efficiently part.
That's right.
Thank you for that. I now recognize Ms. Rosen for 5 minutes.
Thank you. I have so many questions, but I'm going to focus a little bit on our national security and safety, our dependence on foreign sources of energy, and the jobs that would be lost if we lose this industry. So as a matter of national security and safety, we want to reduce our dependence on foreign sources of energy, reduce our carbon footprint, and solar energy industry provides good paying jobs. Last year, there were over 260,000 solar workers in America, over 8,000 in Nevada. Jobs, of course, vary from installation to installation, manufacturing, sales, development, our own local IBEW, Local 357, with apprenticeship programs to train future electricians to work on solar, wind, all kinds of future things. So to all the panelists, I want to tell you at the end of the day, what my constituents care about are 2 things, our national security and safety and their ability to get good-paying, forward-facing jobs of the future. So if we cut this DOE, this proposal to drastically cut the funding, these loan guarantee programs that finance these large energy projects, especially in Nevada, how is that going to impact your research and our jobs and essentially our security if we rely on China for our solar energy?
If I may,
Yes.
one of the important things that we are doing is focusing on the early stage research and development. What that means and what we want to do is that's not the end of the story. We do not want these technologies just to be developed in the labs and to stay in the labs. That's why I'm glad that Martin is here today, because NREL has done a very good job of filling the next part, and that is for what we would very much like, and we as the Department of Energy would like, is to then work with industry in making sure that we get those technologies out of the labs. So at the Department of Energy, there's the Office of Technology Transitions that works with that to help bridge that technology and get it out of the labs. Also, in the labs, and Martin can speak to this, is that the labs can and do engage with industry and strategic partnerships. They do work for industry, and very much we would like to bring more industry dollars to the labs to be able to get these technologies out of the labs and into the market to grow the workforce, and so that we have more solar jobs in America than in other places.
If I can add something to Mr. Simmons' comment, I think it's important to realize that these technologies are not static and fixed in time. These are technologies that are evolving, and so even though there has been recent progress, there's still room for considerably more improvements in performance, cost, manufacturability, and reliability. If America does this research, then we'll have the IP and know-how. We'll be in a position to translate that into stronger companies, a stronger economy, greater energy independence, and more jobs. If we don't do the research, someone else certainly will. The research is there waiting to be done, and then we won't have the opportunity to reap those benefits ourselves.
Thank you. I want to build on that because our critical grid infrastructure, it does rely on a combination of technologies. And how do you know what's early or late stage? Because, like you said, things aren't static, they're dynamic. And sometimes you are doing research, you hit a dead end one time, but that becomes a solution in the next research. So please tell me, Dr. Eglash, can you discuss a false dichotomy between early stage and late stage research?
I think this distinction that some people like to draw between early and late stage or basic and applied is frequently misleading and not helpful. What's needed in most cases is understanding fundamentally what's going on in areas that can be inspired by and informed by real-world problems. That's why having the federal government and industry and our scientists and professors all involved in this dialogue and this effort can be so helpful. If we think of the future of the energy system, communications and information technologies and energy are frequently going to come together around things like smart cities, electric vehicles, and so on. We can't predict that trajectory. We want to make sure that we have the know-how and technologies to allow us to control it and benefit from it.
So we need those on-ramps and off-ramps through all stages of research and development to continue to grow in every single way, would you say?
I would say.
Thank you.
She was right on the money, too. I tell you what, y'all are going to spoil us. The chair now recognizes Mr. Rohrback from California.
Thank you very much, Mr. Chairman, and let me just note that I think that your testimony today is a reason for optimism, and we've actually had the government do some things that seem to be bearing fruit now, so that's great. But the trouble that is, and I will just have to say, whenever Ronald Reagan used to say, and I'm wearing Reagan Brown today, by the way, Reagan, you say that a government program is the next best thing to eternal life on this planet. And Dr. Eglash, I'm sorry, but at some point, we've got to say the private sector can do this. And I certainly buy on to the evidence that we've heard today that we have made great advances so that we now know there are billionaires in the private sector who can put money into this and make it real. The idea that you did suggest, however, which I thought was important, was there are government policies, now that it is real, now that it can be commercialized, that we need to make sure that the government policies of how to get onto the grid, and in fact, there's big debates here over the years as to whether or not the electric companies should be forced to take electricity when it's being produced by a private sector, and thus we would be able to give incentives for even more solar energy production of electricity. I've always thought that was a fairly good idea myself. I'd like to ask you guys about, and I say all of you, I have heard that there's a major technology breakthrough in batteries. And I understand that there's been a lot of money put into it and various approaches, but that at the university, Mr. Chairman, your university down in Austin, Texas, I understand, has had a breakthrough with the fellow in charge of I think he was the inventor of the lithium battery, Dr. Goodenough. Now, he says, and what I understand, is that now they're capable of producing a type of battery that would be based on sodium rather than lithium. Have you heard about that? And if you have, does that have promise, or is there something wrong? Is this just being hyped? Maybe a little bit from each one of you on that.
Sure. So the Department of Energy, we fund research on batteries for a wide variety of batteries that we do not want to put all our eggs in one basket when it comes to battery technologies because of the value of energy storage, both for automobile applications, which is one of the areas where we fund research, and the Office of Electricity funds research for grid scale storage. So we fund a large number. I have heard about this technology.
You don't have any?
I don't know any specifics, but
yes.
there is great opportunity.
Okay.
Yeah, Professor Goodenough, I mean, as you said, godfather of lithium. So
Right.
the technology you're describing, I think, is very exciting. It also depends on batteries and what applications are using batteries. It's the design of batteries very different if you go into automotive or if you go, for example,
Have you
grid
heard of
storage.
anything about
Yeah,
sodium?
yeah. So I saw his article.
Thumbs up or thumbs
I think
down?
it's thumbs up. So the key is there's an energy density thing we have to still work on.
Okay.
But overall, I think it's very encouraging.
Okay, thumbs up or thumbs down on Goodenough sodium battery?
I wanted to put it in the broader context, echoing what some of the previous witnesses have said. The improvement in battery technology is dramatic and continuous, and it's going to help storage for electricity on the grid as well as automobiles.
That's clear. Now, what about this sodium breakthrough?
Very promising.
So you give it a thumbs up as well?
I'd give it a thumbs up as well. It's always new breakthroughs are wonderful to hear about. The one thing I'll just highlight is that battery and storage technology, I think, is an example of something that the private sector already has an enormous incentive to already do this. So I think that's one area that we can think about backing off federal funds.
So you give it a thumbs up. So we got 3 thumbs up and 1 not so sure, but maybe. And let's just note again, and I agree with the last witness who said, somebody put a lot of money into that research, and I know that it's a little basic and applied. I understand your point there, but definitely the basic research has been done, and it seems to me that we should be applauding anybody who invests in things like Dr. Goodenough's new sodium battery. So, and we should, Mr. Chairman, I would hope our job is to see what we can to goose the private sector into investing in it and to actually commercializing some of these breakthroughs like Dr. Goodenough has done at the University of Austin in Texas. Thank you.
Well, I'm not sure the right word is goose the private sector in this setting. Maybe it's charge the private sector with getting that done. Maybe that's a better word. Chair now recognizes Mr. Beasley of Texas.
Thank you, Mr. Chair. And I wanted to ask questions to Dr. Eglash and Dr. Keller. The President's budget request declared some research as early stage and therefore worthy of federal support. Other activities, such as later stage research, also should be immediately eliminated, according to this, given that the private sector is supposedly better equipped to carry them out. However, administration officials confirmed to committee staff that they did not engage with the private sector at all while compiling the budget request to determine what industry would be able or willing to pick up. In your experience, I wanted to know, are the cuts proposed in the FY 2018 budget research areas that the private sector is willing to simply start funding after the federal government cuts them?
The private sector is in most cases unable and unwilling to make up for those cuts for a number of reasons. Much of the research that still remains to be done is across diverse technologies and risky and very difficult for any single company to justify investing in. In addition, the balance sheets of most U.S. solar energy companies are not strong enough right now to support the level of investment that would be needed to bring solar energy to the next level. As you know, government has a long tradition of helping to support technologies like energy in particular, where the costs of projects and the time to pay out can be quite long.
So I think the problem what I'm seeing with the industry taking over, that you have to understand where is the new technology. Let's come back to the battery example. If somebody invents a new anode or a new cathode, which is really promising, the way that you bring this to market is a long, very risky process. And I think this is where we from the research community can work together with companies to de-risk some of this technology to further move it down the market. If this is a tiny little improvement, I would agree that this should be done by industry, but if you have some game changers, so for example, you go from lithium to sodium, this is not just done overnight. So this is a very risky and a very long process, and I think we need to have a balance there to help industry to de-risk some of this technology to move it further down the market.
So, I mean, with that, do you think the federal government should engage with stakeholders in the private sector to understand what research areas they are likely to fund before it proposes to completely eliminate or drastically reduce funding for R&D programs?
I think there's huge benefit to the kind of dialogue with industry you're describing. I think that industry has the real-world experience and perspective and insight that can help inform the research agenda. I think also the fact that we're arguing for federal funding, it's also true that industry should have some skin in the game. This doesn't need to be in the spirit of handouts, and of course many of these federal programs involve different models for cost sharing, and that can be one of the best practices for doing this kind of thing.
Another example is if you look at industry, I think industry is very, very good to take current products and optimize the current products. But I think a lot of times you don't see that industry is changing and doing the step function. So I'll give you this example from my prior job. When we started this idea to what about if you would 3D print the whole car? Current automotive industry would not do this because it potentially disrupts the whole business models. So, but now when you show that research is opening up this venue, then then work with industry and then help to transition this new technology with 3D printing over, which can completely change the way we're doing molding, for example. So this is an example where I think there's a very good synergy by de-risking and helping to push technology into the market, and with this keeping U.S. companies competitive. Because a lot of this research innovations goes on around the whole world, and we here in the U.S., I think we are the world champions in innovation, and I think we have to continue to drive innovation forward to keep our U.S. companies on the forefront of innovation. And I think this is what the federal support research can do.
Thank you. Mr. Chairman, I yield back.
I thank the gentleman. I now recognize the gentleman from Florida, Mr. Dunn, for 5 minutes.
Thank you very much, Mr. Chairman. We have so little time and so many questions. I'll try to be brief, and I urge you to do the same. Dr. Keller, first. In your testimony, you explained the multi-junction solar cells that are on the satellites, too expensive for terrestrial applications, but you're trying to bring them back to Earth. What are the material, structural properties of these cells that are so desirable? And briefly.
So Very briefly, it's almost like a sandwich. You're stacking all these different materials on top of each other. And the way we're doing this right now is very expensive to lay down all these materials, make the intermediates. So the idea really is, how do we bring the technology we have running around on Mars, how do we bring this back on Earth? And this is where we need new innovation to make this next step of the manufacturing. And that's, again, what I talked about.
So it's a manufacturing thing.
The process of the multi-junction cells will stay the same, but the way we make it, we have to make it in a much cheaper way to put this onto our drones and
Okay,
satellites.
that sounds promising. Could you describe the advancements in battery, again, Dr. Keller, battery sciences, and are there actually batteries now or in the near-term future that are capable of meeting utility-scale power demands?
So my personal opinion is that, again, what I tried to say earlier, that batteries are not batteries. So there's a difference on the architecture if you go into a battery into a car versus a battery for a grid. Because as you know, when you drive around, you're limited on space what you can put into a car. So you want to have very high energy density. You want to try to do it as light as possible. On the grid side, well, a lot of times room is not necessarily the limitation.
But I mean, even a battery the size of this room.
Yeah.
Utility scale?
So
Really?
I think we can, and I think also would say the batteries will depend on what the application is. Will we have batteries for 2 weeks of storage, at the grid
Yeah,
level?
when you say 2 weeks of storage,
Yeah.
megawatt hours, day in, day out for 2 weeks?
So I think we will, with certain technologies in batteries, we will go to a grid level storage possibility.
I'm intrigued. So I'm always, next, again, Dr. Keller, the potential for solar to X, solar to fuel. What fuels, and I will say I'm always puzzled that there's this dearth of reporting of research on hydrogen. It seems like such a simple ladder, to electrolysis hydrogen. Am I missing some key?
No, look, you're absolutely correct. When you forecast where the electricity costs might come in the years, it might be that electricity is getting very plentiful. People might argue it might get so cheap that it's not worth to meter anymore. So the key is, what are we doing with electrons? So the idea is, can you take electrons to something else? So you can call this power 2x, for example.
Well, I mean, if you could make a lot of hydrogen, you can store that.
You could do this,
right?
Or you could go through hydrogen as a platform molecule to hydrocarbons. You can use hydrogen to go to ammonia.
Or you can just burn it.
So the idea is, can you diversify electrons? And we're doing more with electrons, just putting them into the grid. So, and this is, I think, where we need research and very fundamental research to go down this path. Yeah.
But it just looked like an obvious one to me. I'm going to turn to Mr. Stein, if I may. I want to focus now on the market forces that have decreased the cost of photovoltaic solar energy. Do you think that's basic science research that's had the major impact, or is that just innovative manufacturing, or perhaps it's government fiddling with tax credits?
Well, as far as the lowering the cost itself, there's no question that has happened, and that's certainly it's incentivized by the tax credits, but that probably would have happened independently of that. But the largest portion of it is almost certainly Chinese manufacturing innovation, because that's why the reason solar panels have become so much cheaper is really because they're being imported from China.
And they're probably subsidizing the manufacturers. That's your point?
Well, they probably are subsidizing at least a portion of the manufacturer, but it's also just they have cheaper labor, they have lower environmental standards, frankly, because some of the components that go into some of these solar panels.
I'm going to interrupt you. We're running out of time. If there were no tax benefits to solar, no investment credits, no mandatory buybacks, all this stuff, would solar be economically viable, and what do you imagine a megawatt hour would cost, if you can guess that?
I think it'd be economically viable in certain parts of the country. I think Southern California, solar makes a lot of sense. Massachusetts, it doesn't.
So within range. In the 30 seconds left of you, Mr. Simmons, you mentioned grid integration reliability issues, the duck curve. Could you describe EERE's focus on utility scale demand, and is the storage of energy part of that focus, and if so, how?
At EERE, we're focused not on the utility scale storage so much. That is really the Office of Electricity at the Department of Energy. However, we work together with the Office of Electricity through the Grid Modernization Initiative to bring together both of our offices to be able to look at all types of storage, whether it is storage at home, storage on the grid.
The truth here is that I've exceeded my time, and as we all know, our chairman is very capable of telling time, and I won't push my, my luck any further. Thank you very much for all of the panelists, and Mr. Chairman, I yield back.
Mr. Simmons, would you like to finish that answer for us?
I'll just finish by saying that we are working together with the Office of Electricity to look at grid scale storage using a variety of different storage techniques, and thinking about the issue holistically, as well as being able to look at integration of building technologies with the grid to be able to hopefully shift some demand around, reduce peaks. Really, when it comes to storage, I think it's important to think about storage holistically and everything that we can do to shift around demand for energy to overall reduce the cost and really drive economic growth.
I think I yield the gentleman another 30 seconds.
Well under 30 seconds. I'm going to ask the panelists, any of you who think you're capable of this, please, 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 get back to us with a white paper on storage. We are not informed well about storage. Thank you.
Thank the gentleman. Now recognize the gentleman from California. Jerry, you're up.
Well, thank you, Mr. Chairman, my good friend in nuclear power. You know, I spent about 20 or more years in the wind industry, some of it at NREL's National Wind Technology Center. Good times. We had developed a theoretical model that showed diminishing cost of energy return as the turbines got bigger, only to be shown later that that was wrong. So, Dr. Keller, is there a similar theoretical curve for solar, or model for solar energy that shows diminishing cost of energy return for solar?
Oh, look, I don't know if there are more like this exist, because right now we're seeing that and you might have a better idea there, but I think right now we're seeing further decrease in solar because it's a complex synergy of all of these different technologies working together, but you might have.
If I may add a comment?
Yes.
Certainly for a solar cell built out of a single semiconductor, there are limits in its performance. And so one of the current areas of research is combining two different semiconductors together. We've heard a couple of people today talk about a new class of materials called perovskites. And one of the things that people are looking at is a so-called tandem cell that involves a layer of perovskites and a layer of something else that might, in fact, be silicon. It's also true that solar cells don't always work well at high temperatures, and so there's work involved in trying to improve the performance of solar cells at high temperatures, because they're often used in environments where obviously the ambient temperature can be quite high.
So there's significant room for improvement in cost.
That's right.
Well, thank you. Dr. Keller, Mr. Stein stated that government funding often crowds out private funding when it enters a given area. Have you seen government funding crowd out private funding in areas of NREL's research?
No, look, I think there's a synergy, because when you have a strong fundamental science portfolio with the people who understand what industry needs, and look, when you look into this, a lot of our research, when we go, perovskite is a good example. I mean, you're doing a lot of analysis up front to see what is really some of this new game-changing technologies based on some of the analysis. And of course, a lot of the fundamental science also has input from industry, where a lot of our research is not just created out of a vacuum. You're having committees, you're having panels, you're inviting the top researchers and getting feedback. So I would argue that there's a nice synergy by having a strong fundamental science, and then you're tying also this with industry. And this is where you then get the synergy and the most advancement of the technology.
May I make a quick
Sure.
comment about that? And in terms of the administration's position here, we want to spend, limited taxpayer, some of the limited taxpayer dollars that we have on early stage research. However, we also want very much for this work that Martin was just talking about, as in this the synergy between the national labs. We want to leverage the investments that have been made at the national lab through taxpayer dollars, and then leverage that with NREL, the other national labs, also working together with industry to get those out of the lab. So that work that he was just talking about, I want to stress that the administration very much supports that.
I'd like to believe you. Dr. Eglash, could you explain why the companies in the Bay Area PV Commission don't carry out research in certain areas that might actually benefit their long-term bottom line?
You mean on their own?
Right.
Yeah. There's a number of reasons. One is that in many cases they simply don't have the financial wherewithal to do so. And to your earlier question about whether federal support might crowd out private investment, I think we can point to several examples where the opposite is true, and federal support actually attracts increased private investment, because at that point there can be a leveraging of the investment and you can reduce some of the barriers that the private sector would otherwise see. In the case of the companies that have chosen to join the Bay Area PV Consortium, they're contributing cash alongside of the federal investment. They're also contributing know-how and insights, and they also provide a path to commercialization for the innovative technologies that are being developed. So far from being a handout, the idea is much more of a partnership.
Kind of a leverage to get industry to invest more.
I think there is definitely a leveraging.
All right, well, thank you, Mr. Chairman. I'll yield back.
Thanks. The gentleman now recognize Mr. Tonko for 5 minutes.
Thank you, Mr. Chair, and welcome to our witnesses. I'm pleased that the committee is looking at this issue, and I strongly believe that we must continue to support and fund renewable energy research. The Office of Energy Efficiency and Renewable Energy has a proven record of delivering innovative technologies that make renewable electricity generation cost competitive. As we push our innovation economy forward, groundbreaking new technologies become that much more essential. EERE allows exactly these kinds of technologies to take root. I could not be more proud of these first-of-their-kind and game-changing new technologies that this program is helping to make a reality. In 2011, through the Sunshine Initiative, we set out to reduce the total cost of solar energy. We set ambitious goals and we invested wisely. This past September, the Sunshine Initiative successfully met the utility-scale solar cost target of 6 cents per kilowatt hour 3 years earlier than anticipated. While we should herald this success, I worry that there are interests who would have us reduce our commitment to renewable energy research. China currently invests more than double the U.S. commitment to renewable energy research and development. And while other countries continue to pioneer innovative renewable energy and hyper-efficient technologies, President Trump and Republican leaders are working to eliminate or gut most cutting-edge programs, including Advanced Research Projects Agency Energy, the ARPA-E, and the Office of Energy Efficiency and Renewable Energy. The budget proposed by the President would cut funds for EERE by 70% and eliminate ARPA-E entirely. These massive cuts defy common sense and will cost us dearly in the future by abandoning innovation and weakening America's global competitiveness. So we must do more to support these groundbreaking initiatives. We've heard that the Sunshine Initiative is a political goal, not a research goal. However, it seems to me that the purpose of investments in energy technology are to advance the technology so it functions more efficiently. So, Dr. Eglash, could you explain why the Sunshine goals were a completely reasonable choice for focusing government investment?
The Sunshine goals created an inspiring target of cost and performance that then mobilized the attention of researchers and industry. At no point did it seek to pick particular winners and losers beyond a support for solar energy. If I can just comment briefly, for several years I was a utilities commissioner for one of our nation's small municipally owned utility, the utility of the city of Palo Alto, California, and there, through purchasing and deploying utility-scale solar, we were able to reap the benefits over years of a technology that doesn't need a continuous source of fuel, like gas or coal or oil. Once you've deployed it, it's then free, other than a modest operations and maintenance cost. And in that same way, the nation's increasing use of solar and renewable energy can help strengthen the grid and provide greater energy independence.
Thank you. And Dr. Keller, can you tell us a little more about how the Sunshine Initiative contributed to falling prices in solar energy?
The Sunshine looked at this holistically, how you can drive down costs through more innovation and research. And when you look at this, in what areas research was done, just to name a few, it was in general about the efficiency of the materials, the deposition of these materials, better understanding of the photoabsorbers, such as silicon or cadmium telluride, the buffer layers, the electrodes, the new module materials, and power electronics. So it was not one little step which led to this. It was holistically that you're looking into all the different components to further create research and the innovation to further all decrease the cost. And I think it was very successful. When people say it was all done by China, I would like to compare this to when you look at First Solar, which also the biggest US manufacturer of solar panels, and they also, with cadmium telluride, decreased the cost significantly here in the US because of some of this research going on in activities such as sunshot.
If I may add a specific example to the story, the way that this worked was industry would identify certain needs for lower manufacturing costs, needs, for example, for a better encapsulant, the coatings that keep humidity away from the solar cell itself. But they wouldn't propose what the particular solution would be. That came from the researchers. And while it's not clear whether you can call that basic or applied, it is clear that with the help of EERE and the Sunshot goals to focus attention, we were able to have that kind of synergy and leverage between identifying problems and then finding promising solutions.
Which would obviously increase our competitiveness as an American solar industry. Gentlemen, thank you very much, and with that, I yield back.
I thank the gentleman from California, Mr. Takano is recognized.
Mr. Chairman, thank you. Mr. Simmons, we've heard that the Sunshot Initiative may not have been responsible for the costs of solar installations falling, as the cost decline may have largely been the result of Chinese manufacturing innovation. However, China has invested over $50 billion in renewable energy investment since 2012, and upwards of $100 billion recently. During that time, China has become the world leader in solar panel manufacturing. I think we can agree that the investments in China are overwhelmingly made by the Chinese government. While you discuss the importance of the free market, the countries we are competing against in this industry do not seem inhibited from using government investment to throw the game in their country's favor. Do you believe that there may be a government role in avoiding ceding control of this vital industry to China?
It's the administration's position that there is a government role for early stage research and development.
Okay, so so you do believe there's a government role?
Well, that is the administration's position.
All right, and we've heard this. You've heard the discussion about how that's not so easily defined about what early stage is versus.
Sure.
And that's a legitimate point for discussion. Does anyone else want to? I mean, Mr. Keller or Mr. Eglash, would you like to comment?
I just wanted to point out that the solar energy industry was largely created by the United States during research going back 20 or 30 years, and it's only been during the last 10 to 15 years that much of the solar energy manufacturing industry has moved overseas, particularly to China. But with the evolution of these technologies, we have an opportunity to bring significant portions of that industry back to the U.S. with all the ancillary benefits of doing so.
So
Dr. Keller.
when I just can jump in there for a second, I fully agree with this comment and what I said, for example, on this next generation of materials. If we are successful to keep and drive this innovation forward, this is also a chance, in my opinion, to get the supply chain for whole solar manufacturing back into the U.S.
So this next generation of materials, do you think that's something that's left to the free marketplace, or with vis-a-vis our competition with global competitors, is this early stage? I mean, it's really not early stage.
Perovskites is still very early stage, but I tell you what's happening right now, that where we, as in the US, I think we still have a leading position in this new next generation of materials. But this said, everywhere I travel, people jump onto this like crazy, and our fear is that China, for example, starts to invest significant more money in this next generation of materials. And so the key is we have to continue to drive this innovation, and not only on the material side, but then you're combining this with the next generation of manufacturing side.
How do you answer folks who say that government's really not good at does not do a good job of deciding these sort of things? And it seems to me that there might be some market incentives for people to invest in this research. How do you answer that?
There certainly are market incentives in some of these areas, but we're living in a particularly promising moment with respect to materials science, chemistry, and chemical engineering. These are technologies that can help solar energy, energy broadly, including storage, and a variety of other technologies. While there is a vibrant materials and chemistry industry today, it's not sufficient in and of itself because these technologies are so broad and so many of the hugely promising things we could do are risky enough, diffuse enough, or have a sufficiently long time to pay off that we'll be in an even better position if we also have some federal support for research in materials and chemistry.
And
Go ahead, Mr.
perhaps,
Keller.
if I can jump there, when you look at perovskites, what's happening right now as an example, which was at the beginning very risky. Now we're getting to this point where people say, "Ooh, this could be really exciting." Now we're seeing interest from certain startup companies. They're coming out of Stanford. They're coming to us. They're trying to collaborate with our scientists to advance this technology. And I think this is an example where, when you start how this all was initiated, came from very, very early stage research, then was narrowed down. We tried to overcome some of the big principles around these materials. And so this leads, in my opinion, if you continue to drive this innovation forward, will have the potential to revolutionize solar.
We might be missing a real opportunity to stay ahead of the game in this technology. And it would be foolish for us to adhere to a rigid ideology about using that ideology to not make a good judgment here, to be involved in this next stage of research. Mr. Chairman, I yield back.
Thank the gentleman from California. It's time for our friend from Colorado, Mr. Perlmutter.
Thanks, Mr. Chairman, and thank you to the panel. I've been around long enough to know that early stage and late stage and basic and applied, from Congress to Congress, from administration to administration, we kind of whipsaw the Department of Energy, saying, okay, we like early stage, we like late stage, but sometimes late stage becomes early stage, and I'd like to run a clip from a TV report from yesterday about the National Renewable Energy Lab.
Keller is a research scientist for the National Renewable Energy Lab, or NREL, in Golden. When he started here, he wanted to change the world.
Of course I wanted to change the world.
It all started quite unintentionally about a year ago for Wheeler. He was working on an infrared detection project that wasn't working very well. His first reaction...
Ah, crap. Yeah, it was, well, this isn't going to work.
On his bike ride home, a light bulb went off.
This could be big.
He just might have created technology that could be used in a very different way.
It was a Eureka moment.
Scientist Lance Wheeler explains.
We coat a piece of glass with a metal halide perovskite. That metal halide perovskite has a very low formation energy. And so because of that low formation energy, molecules will intercalate into the crystal structure, disrupt it, and make it turn transparent.
So in other words, as the window darkens, it actually generates electricity. It's like the combination of transition eyeglasses and solar panels.
It is amazing. I mean, it was something that I said, if this works, this is going to be huge.
That could be true. 75% of energy used in the U.S. is by commercial buildings.
In this technology, you'd be able to not only convert electricity, but also mitigate solar heat gain. So in those summer months, you'd save on your AC bill, and you'd also be generating electricity. So it would be really combating all of our waste energy use in the United States.
If true, this research scientist will be in good company. Ford, Edison, Wheeler?
Maybe.
The end of Rue, Channel 2 News.
Cool. Really, pretty inspiring. And I just, again, obviously I'm very proud of the National Renewable Energy Lab. I'm proud of the Department of Energy, just because you have a lot of very bright people there. So, Dr. Keller, if you'd like to comment on that for a second. And then after that, I have some questions for my brothers in the bar. So.
Thank you very much. Look, this was a video to show you how science is done. So if you have smart people and creative people, and they have experiments that went wrong, and they say, what about this? And they change and adapt. And this is something which makes the National Lab system, DOE, but also the scientists, this is the strength of the United States. I think we have the best, the most brilliant people doing this. And when I compare this again through my traveling, where we have the edge, if you compare us, our science, to other countries. We are still much more creative. We live in a system which enables creativity. And I think this is why it's so important to continue to support researchers through federal funds.
Okay, and I thank you for that. And so, you know, Mr. Simmons, I was encouraged by some of your comments concerning the National Renewable Energy Lab, and really, you know, whether it's basic science or applied science, I mean, depends, you know, what you want to call it, but it's sort of on this continuum. But one of the things I am concerned about, and so I'm going to ask some math questions of my attorney friends. You know, at $207 million, that's the solar budget from last year for 17. It's going to get cut to $70 million, okay? So let's go with the higher number, the $207 million. We are in the throes of dealing with a tax cut that's going to cost the country about $1.5 trillion at best. Do you have any idea how many solar energy budgets fit into $1.5 trillion? And I'll give you like 2 or 3 seconds, not embarrass you, because we've got the scientists here, but I've done the math, so I'll help you.
Well, there was a reason I went to law school.
Okay. Mr. Stein?
I'm not going to do the math in my head.
All right, so, and I don't want to make, you know, I went to law school, and I'm proud of being a lawyer, and I'm proud you guys are lawyers, but the answer is 7,142.85 budgets for solar energy. Let's round it up to 7,143. Let's take all of the EERE budget for 17, which is $2,090 million, reduced to $636 million. At $2 billion, let's round it down just to make the numbers easy, at 750. And so I appreciate, gentlemen, you know, some of the questions about, you know, spending too much and cost overruns, but everything is relative and in perspective. These laboratories, and Mr. Simmons, you are now, you know, not burdened, but you are tasked with really working with them and getting the best out of them, because they do bring good things to light. And these cuts that we're going to face are really, you know, just, they are paralyzing. And so I just appreciate this panel being here. I appreciate some of the, you know, the comments of our engineers and scientists, as well as the kind of the focus that you gentlemen have, you know, as to what should the government be doing. You know, what is our role? But we do know that we are making some substantial steps, and I don't want to see us to step backwards from that. This country is too good for that. And with that, I'd yield back to the chair.
I thank the gentleman. I thank the witnesses for their valuable testimony and the members for their questions. The record will remain open for 2 weeks for additional comments and written questions from the members. This hearing is adjourned.